Hello everyone, my name is Wilson and I am presenting a machine learning project for the course project purpose of managing machine learning applications. Here as a problem, I have taken a stock market movement prediction to apply the machine learning solution. Stock market prediction is normally considered as a highly challenging topic and requires careful analysis of various factors. Why we are using machine learning in this one? So basically we have a problem to resolve and computers can make quick decisions and calculations and accuracy and can automate decision making without interfering with human emotions. And here machine learning can help it because it can use for predicting the stock movements. And the user's perspective, traders and institutions will be finding it useful to aid their decision making. So coming to the crisp DM business understanding, so defining the problem. The problem is how to accurately predict stock market movements, and the target users are normally stock traders or financial institutions. So the decision making should be accurate as well as quick, as the opportunities will disappear very fast. Manual analysis is normally considered as time consuming, and when it is mixed with the human emotions, there can be a possibility of errors as well. So now how we will define the success of this particular model. So in order to accept the success of this model, we are setting a 50% improvement in profit when applying this ML solution. This can be later tuned by varying different features parameters for more accurate predictions. So some factors to consider is the analysis should be completed in the shortest possible time, maximum within a minute, to help the traders to take the decision as early as possible. And for the sake of explanation, this example is calculated in Excel, but it can be moved to any programming languages. For the solution validation plan, we have extracted around 45 calendar days data from a stock market trading application which contains 2250 records, out of which 2000 records we are considering for training purpose and 250 records we are using for the validation purpose. As identifying the features, we are using two technical indicators called MACD divergence and Schaff index. For evaluating the model, we are using multiple regression to determine the model accuracy and varying the input features to evaluate the model performance. So now coming to the ML system design, cloud or edge. This need to be hosted in edge machine so that the decision will be quickly available to the user based on the data available on his machine or his personal database. Offline learning or online learning. Due to high volume of incoming data, the learning need to be trained in a offline mode. And regarding the prediction, this need to be on online because the user need to get instant predictions whenever there is a market move. Now we are warning or factors when deploying this in production. The market condition can greatly influenced by various political factors and social factors or monetary policies, and that can set market highly volatile or it can start a new trend. Any latency in getting the data that can impact the prediction effectiveness. As there are large number of technical indicators, the effectiveness of the system may vary when majority of the traders involving in the market is shifting their focus into a different technical indicators that will impact the model prediction. And finally, there is no technical indicators that are giving 100% accurate result, and either all these indicators will be either lagging or leading, and the market may not follow specific indicators as the human psychology will be involved during any decisions happening in the stock market. For model comparison, now let us explain in Excel. Here in the first sheet I have put all the 2000 test data, and the training data I have put in two different sheets, first evaluation and the second evaluation. So here I am considering two columns, increase in stock index and decrease in stock index. These are the two output variables, and these are the two features we are considering. One is data histogram and SHAF index. So the first prediction is based on, regression is based on increasing value based on data histogram and SHAF index. I have already calculated and I have summarized in this area. Here we can see that standard error is 33 and adjusted R square is near around 0.002, and the decreasing stock index I have portrayed over here. This value we are trying to predict based on these two features, and the result is portrayed in this part of this one. Here we can see standard error is 14 and the adjusted R square is coming around 0.004. When we are applying this prediction into the test data, here we are getting predicted value calculated over this column S and T. This value we are using in conjunction with the existing decisions to determine whether we need to take a trade or not. When applying, we are getting a statistics like this, and here we can see there is a 55% reduction in number of trade taken, which can effectively decrease the trading cost, brokerage fees and security transaction charges. And success trades, here we are seeing a 33% reduction, which is adverse effect, but it is set off by reducing the failure trades. Failure trade is drastically reduced when we are using ML solution. Almost 98% of the failure trade is got reduced when we are applying ML solution in conjunction with the normal trading decisions. And success percentage, 48% reduction in success percentage and 94% reduction in failure percentage. And coming to the gross line gain loss part, without ML it was 739 point gain, and with ML it is 2947, almost nearly 400% improvement in profit. As a secondary test, we have considered a slightly different calculated features like histogram delta and SHAF delta. So this is basically the difference between the current value and the previous value of the respective technical indicators. And the similar way, I have run a regression for the increasing set with these two different features, and here we can see we are getting a slightly different regression statistics. Similarly for decrease set also, with the new two features, I have run a regression and these are the result portrayed over here. And when you are applying this model to our test data, we are getting almost similar performance but slightly lesser than the first one. So I have tabulated this in the Excel. Here we can see with the initial features with actual MACD and SHAF, standard error is 33 and the revised one is having slightly lesser standard error. But when you are checking the adjusted R square, the first model is having slightly lesser value. This is for the increasing in index value. Similarly, for decrease of index, we have somewhat similar result with a slight variation in standard error and R-square, but the first one is giving slightly better regression statistics. This slide represents when we are applying the result to our test data. So both the models, it is performing somewhat similar. The first model is giving 399% improvement in profit, and the second one, with the altered features, is giving 385%. So as a conclusion, the test one with the actual MACD and SHA-4 test data was giving slightly better performance than test 2. So as I mentioned earlier, this prediction result have to be used as another technical indicator in conjunction with non-ML decision making criteria, as we are able to produce almost around 400% improvement in profit. Thank you.